Hello everyone, welcome to another Finxter tutorial. In this tutorial, let's learn how to find the unique elements across multiple columns in a Pandas data frame. Let's say we have a data frame as shown here. This data frame contains three columns, column 1, column 2 and column 3. Column 1 contains names of few persons, column 2 contains the names and column 3 contains some random integer values. Let's say we have to find the unique elements from column 1. How do we do that? We can use the function from pandas, which is pandas.uniqueof. So let's see pd.uniqueof df of column 1. Sorry. Okay. So when you run this, you get unique elements from this column. So if you see here, Alice has two entries here, but then when we are counting unique elements, it shows up only once. Similarly, if you want to find the unique elements of column 2, you can just address the column that you want and then run the program. So you can see that here Steve is repeated twice if you see, but then in the unique elements list, Steve shows up only once. Now it's not that we can use only pd.unique. We can also use np.unique. For example, if I say np.unique of column 2, then it gives back the unique elements from column 2. Similarly, you can say np.unique of column 1. Also, you can convert this to a set. As we know, the set element should always be unique. So when you convert something to a set, if it has repeated occurrences of a particular element, then only one occurrence of that element is given back. For example, when you run this program, you will see that although Steve is repeated twice, when we are converting it to a set, only one occurrence of that element shows up. So this is another way of finding unique elements within a column. Now, what do we do when we have to find unique elements from multiple columns? Let's say we want to find unique elements from column 1 and column 2. How do we do that? We can merge these two columns and then find the unique elements. So, how do we merge the columns? To merge the columns, we can use the pandas data frame dot values property. So, how do we do that? Let's say df of colon 1 comma column 2, and the notation is to have double square brackets here. Now I'll simply run this. As you can see, both the columns are returned. So now I'll just say dot values. This is a property and not a function, so don't use the double brackets here. Now when I run this, we can see that it is converted to a 2D NumPy array, right? Now we can call the unique function and return the unique values. For example, once this is done, maybe I'll say print of np.unique of this value. So let's see what happens when we run this. Yes, so this returns a NumPy array with the unique elements. Now let's try to use pd.unique. We see an error here. It says buffer has wrong number of dimension, expected 1, got 2. That's because when you see the documentation of pd.pandas.unique function, it expects a 1D array-like object, but then because the array that we've passed is a 2D array, we see an error here. Now let's see what happens when we are using set function to convert. So now I'll run this. Again, unhashable type numpy.end array. It's because it is a two-dimensional array. So when you're converting something to a set, it must be a one-dimensional array. When you send something which is two-dimensional, you get a unhashable type numpy.end array error. So how do we fix this? So we know that numpy.unique can handle the 2D arrays. That's because internally it converts the two-dimensional arrays to one-dimensional array and then finds the unique element. So when you want to use set or when you want to use pd.unique function, you have to convert the multidimensional array to one-dimensional array and then use the function. So how do you do that? To convert a multidimensional array to a one-dimensional array-like object, we can use numpy.flatten or numpy.reveal functions. So let's see, let's just use numpy.flatten. Now when we run this program, we don't see any error because internally this converts the two-dimensional array to a one-dimensional array. Let's see here. Let's say I'll say dot flatten off and I'll comment this for a minute. Now when we run this, so what we see here is both of these column 1 and column 2 are being merged and all the extra multiple occurrences of the elements are present here. Now when we convert it to a set, when we convert this to a set, all the extra elements are removed and only single occurrence of an element is kept. So yeah, you can also use pd dot I'll just comment it. You can also use pandas.unique now. So because it is a one-dimensional array, no error is thrown and you get the expected result. Instead of using df dot values to merge these two columns, we can also use pandas dot concat function or even numpy dot concatenate function. Let's try using pandas dot concat. So we'll use pd dot concat of df of colon 1. 1 second, I'll just remove this. df of colon 1 comma df of column 2. So there's a square brackets that is missing. Okay. So when we run this, closing parenthesis is missing. Let's see, there is some error here. There is a parenthesis here. There is a parenthesis. So we have to concatenate this one. So there is an extra square braces here, which I'll remove now. This should be fine. I'll run this program. Okay, so now we've got the unique elements. So now pd.concat can be used to merge these two elements. After merging this, instead of pd unique here, you can also use set of to convert this to a set. Yes, or you can also use np.unique of np.unique and it works. Now, instead of pd.concat to merge these two files, you can also use np.concatenate to merge these two columns. So when we run this, we get this. We get the elements which are unique. So these are about all the methods that can be used to merge two columns and then to find the unique elements across the multiple columns. We hope this has been informative. Thank you for watching.